connect? Can I connect? Can I connect?
Oh yeah, we got it. We're back.
In a world with VA problems. AV problems? Oh, VA problems.
Ha!
Now, in a world where Crawlmaster controllers don't program themselves, we need some help. What we're going to do today is have our computer go to sleep. We are going to run through the installation and use of our Crawlmaster programming suite. We have this on the website as a zip file where you can download everything that you need, including the drivers for the little chip, what is this? The CP2104 that you can get from Adafruit. We've been selling these on the site pre-assembled, and you can also get them directly from Adafruit if you want to save some bucks and do it yourself. At this point, we do not recommend you use the FTDIs because there's a lot of cheap ones out there, and it's great that they're cheap, but they can also kill your computer. They are almost all knockoffs at this point, and they also don't have amp protection. So if this thing goes down, or if you have a short, if you don't have the back of this insulated, you throw it down on a metal table, or if it hits your Crawlmaster ESC somehow, that can go directly into your computer. Best case scenario, it ruins a USB port. Worst case scenario, it fries your entire computer. So we would recommend you go with these Adafruit Scilab component. What are they? They're not FTDIs. They are, let me know in the comments, whatever they're called. FTDI friend? USB to serial device. Yes, it is an FTDI device, but you get the drift. All right, on to it. So let's go to my monitor on the overhead, and I will show you. You're going to download the Holmes program suite. It is located on the actual Crawlmaster web pages. So you can go to the Crawlmaster itself as if you're going to buy it, scroll all the way down, and it's going to have this zip file. You unzip it, and what you will find inside this is the ESC configuration tool. I have 1.68 included right now because that's what I know is stable with all this stuff. You can probably download the 1.7 from AM32 and be just fine with that. We have the FTDI friend drivers, which actually comes inside of a zip folder, so you want to unzip that. We're going to extract all, I already have it extracted here, and this is the first thing you want to do. You will install your FTDI driver friends. Since we recommend Windows 10 for this, we're going to use this x64. I've already installed it, but I'm going to do it again for you. Scilab driver package install. You hit next, you hit finish. You may need to restart your computer at this point to get it to work. But what we want to do here before we go any further is we're going to go to device driver, device manager, and we're going to plug in our device. And you will see what should happen. Plugging it in, it is going to pop up under ports, common LPT right here. What we want to do is we want to see that Silicon Lab CP210X, this is 2104, USB to UART bridge. And it tells us right here on COM3, just to be sure, we're going to double tap that. This device is working properly. That is what we want to see. If you want to see the port settings and the drivers and all that kind of good stuff, it's in here too. It doesn't really matter. What we need to know is that this is recognized as what it is and that it is working properly. So we are good to go. And a note it's on COM3. Once you have that, you can go back up in your file folders. You can see right here that we have two of these binary files. This is what we're going to upload into the ESC. And to do that, we're going to use the ESC config tool folder for Windows. Crawlerconnector.exe, this is the actual software. You can pretty much ignore everything else in this. You can also take this crawler connector exe and you can throw it into your 1.7 downloaded. If you've already got AM32 on your system, then you can just throw this exe into your file folders and it should work just fine. So here we go, crawler connector. First thing we need to do is we select the port. It's already plugged in, so it's recognized on COM3. Select your COM3 and connect. Since we are using a regular old FTDI/UART, we are not going to hit this button. We are not going to connect with a flight controller. If you wanted to use a flight controller, use this software, that is what you would hit. You'd check that box, and then we would move on. We're going to update our ESC, so we need to flash it first. We're going to load firmware. hit this load firmware button. We're going to go back up one so that we can get the 1.2 binary. This is the fix that will allow you to run 4S LiPo on pretty much any of the KVs that are allowed on the ESC. It's going to run a lot cooler. I would highly recommend you go to this 1.2. If you don't want to get there and you don't want to do anything as far as programming, then you would do just the temp fix 1.1. But I would highly recommend we do 1.2. So we have that there. But before we load this firmware, you can see the load firmware button popped up. We're going to have to connect to the ESC. So let's go to the overhead camera now, and I will show you that. All right, so here is our FTDI friend. We have these pins. The ground is located right here on this corner. It says G&D on the board. Let's see if I can see it. Yeah, tiny letters G&D right on the edge of that board. And this video is brought to you by my 5-year-old's fingernail painting polish party, as you can see. Then our signal, TXD. There's a little arrow. Let's get that to show up on the camera. Is it gonna? All right, you see that little arrow. You may have to pause it to see what's going on, but that is our pin. As you can maybe see, I have actually taken off all the pins except for the 2 that I'm using. We have our signal right here. We have our ground there. So that is what I'm going to do. I'm going to plug into those. And the way that we do that is I'm going to use this JST right here that comes off the board, and I'm going to put the ground right into that ground, GND, on the edge of the board. Then I'm going to take my signal wire, and I'm going to use the signal side that is going to be yellow on mine. You may find that yours has white for the signal. Either one is going to be the lightest color. It's going to be the opposite side of your ground. We're going to plug that into it. So let's get a little sideways view. You can see how it's plugged in, how it's orientated. Whose hands are these? That's interesting to look on the camera. So you can see, plugged in just like that. You're going to focus. There we go, focus. Now, what we need to do is we need to power up our ESC. So I'm going to plug in my battery. I'm using a 3S LiPo on this. For programming, it really doesn't matter. And I don't have a motor hooked up, so you can't hear the beeps. But when it's plugged in, it'll at least beep a little bit to tell you. All right, let's switch back to the computer. And now we are going to hit this load firmware button. Oh, no, sorry, I need to connect to the ESC first. We are going to read our settings first. Connecting to the ESC, connected right here, bam, connection settings read okay. Now that we have connected to the ESC, we can hit the load firmware button, or I'm sorry, flash firmware because we already loaded, but let's just run through that again. We are going to load our firmware, the 1.2 binary. Now the flash firmware button comes up. We hit our flash firmware and we get to wait. Since we are flashing the firmware, it takes a little bit of time. Once we have the new binary flashed on there, it is really fast to update our settings, like a second. It is blazing fast. It's awesome. But right now we're just uploading, 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 and still uploading. So once this is done, we are pretty much ready to rock, but I'm going to go through all the settings for you and tell you exactly what they do, at least do my best, and then we will program. So on the Holmes Hobbies Crawler Edition ESC Config tool, this is more or less what your stock settings are going to be. So we go to the Settings tab here. If you want to read the settings, then that will tell you what is exactly programmed on your ESC, and it may be slightly different depending on which firmware you're coming from, but we're going to read the settings, connecting to the ESC, connected settings read OK. So all of these will be exactly what I have programmed on here. Reverse rotation, if you don't want to just switch 2 wires on your motor, then you can hit this reverse rotation. Let's say that you can't get to the wire so easily or whatever. I don't want that. Complementary PWM. This is the same as active freewheeling. This is the same as active drag. This is the same as many other things that people call in the industry, but essentially for crawling, I would highly recommend this. This essentially turns on your drag brake while you are on throttle. So we're going to keep complementary PWM. Variable PWM, not so critical for our use. However, this keeps the commutation frequency off of the switching frequency. So as soon as our commutation frequency gets close to being a multiple of our switching frequency, which is basically 24 kilohertz, it moves the pulse width modulation around just a little bit. It makes the throttle act a little bit more linear. This would be a lot more noticeable, I believe, if you had a prop on the motor instead of driving, because of the load changes are a little bit different. But that is, I would suggest keeping that. It does seem to make it a little bit smoother around the throttle band. Bidirectional. This is forwards and reverse. So in a crawler, we definitely want this. Stuck rotor protection. If you are crawling and you are giving a little bit of throttle to stay in one spot, this will actually activate and make your rig lose power. I would not recommend this in a crawler. This is very useful for in a UAV situation. So if you want to turn your Crawlmaster ESC into a UAV, and let's say your UAV crashed and the rotor's trying to go, but it's stuck against the ground, so this would shut your ESC down. You don't really want that on a crawler. We're in situations to where we essentially, stall the motor all the time, so we don't want to use this. Brake on stop. This is drag brake while we are stopped. You definitely want that at neutral, at least in my opinion, if you're a crawler. Stall protection. The stall protection is essentially like a semi RPM lock. When the motor tries to fall below the natural, we set it up over here. This startup power is what controls this RPM. But when it falls below the stall RPM, it actually gives it a bump of power. You can't feel the bump of power, you don't recognize the bump of power, but it gives you that RPM lock, and it'll make a weaker motor feel like it's a lot stronger down low. We don't do this at higher RPMs. This is just a low RPM thing, so you get that really solid feel when you're down low. You don't get a lot of RPM changes under load, but it does stall at higher RPMs, albeit not all the way, because you're going to still be adding throttle. The Sinusoidal Startup. This is what gives us that really good low-speed control. This forces the motor to start up at a slower speed than its inherent motor design is going to let it. So this is why the Crawlmaster ESC starts up slower than, let's say, a Castle ESC, because we're essentially forcing the motor to start up really slow. The telemetry, I do not know if on 1.2 we have the telemetry available yet, so I just skip over this. Using Hall sensors. It is an option, but this is not tested on 1.2. I would not recommend that you add this. Currently, the use of Sinusoidal Startup is also exclusive to the use of Hall sensors, so if you use Hall sensors, your startup is actually going to be worse than if you use the Sinus Startup. So at this point in time, I would recommend that you do not use the telemetry, you do not use the Hall sensors, we do not use the stuck rotor protection, and reverse rotation is kind of up to you. All right, let's go over to these settings. Timing advance. I highly, highly recommend that you leave this at 15 and do not touch it. If you do want to change this, you can click on these and you can hit left and right. You can hit up and down, or you can slide it. See, there's not a lot of range on this. If you have it too low, it's going to not commutate well. At high RPMs, you could actually smoke your components. And if you have this too high, then you'll be adding more heat into your system than it really needs. So at this point in time, I'd recommend you just keep this at 15. We will do some more testing. You're welcome to test this yourself, but just be really careful. If it acts odd, shut it down, put it back to 15. Motor KV. This is how we're going to, at least in the future, tune our startup. On this particular firmware, I have not noticed a difference. I'm not sure if it is quite working yet, but it doesn't seem to be quite working. But for the time being, I would recommend you get this pretty close to whatever you're going to be using, just so that when we do move forwards that you'll have the right settings on there. Motor poles, this will also be used in the future to tweak and tune our startup routine. Right now I'm using a 14-pole motor, so we're going to just keep that on 14. I do recommend you set it to the poles that you're actually using. How high can we go? We can go up to 36, and we can go down to 2. But for the time being, 13. 13-pole motor, that'd be an interesting one. For the time being, I recommend you do set it where the actual motor is, at least as close as possible. And in the future, when we unlock a little bit more features, it's going to work really well for you. Startup power. This actually is the transition from sine startup to regular 6-step commutation. If you feel a little blip of power, if it tends to have a big jerk in between low speed and high speed, then this is too high. You're going to find with Your stock programming, this is going to be either 90 or 100 most likely. I would recommend with the 1.2 firmware, especially if you're running 4S LiPo, to bump this up to 110. If you are finding that the rig likes to, jerk and shake at a certain point in the throttle when you're going in between that sinus and the regular commutation, then you want to increase this startup power. But again, if you find that it's kind of jumping too large and you have like big gap in your throttle band, then you want to reduce that. That is a really good way to kind of tune that to be really smooth between the two. We are working to essentially get rid of this in the future so that it will be self-tuning with a PID loop while it's running and you won't have to really tweak this yourself. But right now, it is something that we have to tweak. We are working to make this more universal with a self-tuning PID though, which is really cool. PWM frequency currently not available on this to test and tweak and tune, but in the future we'll probably unlock this. You can go lower than 24K and that will help us out as far as heat, but it'll also be audible. So yeah. Beep volume. The motor essentially is going to be a speaker of sorts when it arms, and some motors are quieter than others. Outrunners are typically really loud. We have this set at 5 to work with outrunners. But if you're running like a 6-pole in-runner or something like that, you're going to want to probably move that up so that you can hear a little better on arming, but 5 is typically enough to be heard. Drag brake power. This is exactly what it sounds like it is. We're in a crawler, so we're just going to run full drag brake power. The sign startup range, stock, you're probably going to be down here at 14 if I remember correctly. This is kind of like a throttle curve. If you add higher numbers to this startup range, you're going to get more of this sinusoidal startup into your throttle. So this is a smoother throttle, more like having a curve on a castle, and this is going to be a more aggressive throttle that gets into normal commutation. So if you want more low-speed control in your throttle rather than high-speed control, then I would recommend somewhere between like 14 and 20 on the settings. All right, before we leave this, we're going to save settings. Bam. Write EEPROM successful. We are ready to go. Let's see, a couple of other things over here on input. Low voltage cutoff. This doesn't have a decimal point right here, but we definitely want to turn low voltage cutoff on just to be sure that it is there. And then I'm actually going to go up to 3.4 volts. We're going to add the decimal plate in the future. And if you want to double tap for your reverse, then this is the way to do it right there. I don't want that. So we are going to save settings on this. If you also want to change where your radio arms, if you don't like having to add 60 clicks of throttle to get your arming on there, then you would change this neutral point and just try to figure out where it needs to be for arming. Or you could just increase your deadband, honestly, if you wanted to jack that up to 100, then that would be fine. I'm going to reread my settings on this. There we go. As you can see, this went back. So I'm going to redo that. Then we're going to save our settings. I'm pretty sure it already wrote. It's so fast on here. So that's it. One thing that I would like to mention on the low voltage cutoff, when you are at really low speeds inside the sign startup range, it may not operate correctly. So I would recommend every now and then you give a little blip of throttle to make sure you're getting into the low voltage cutoff. We're going to fix that on the next. We're doing a little bit of investigation to see if that's it, but we have had reports that the low voltage cutoff is not working. And my assumption, because I've had it happen to myself, is that you're just crawling really, really, really slow. And so it is currently not recognizing the low voltage cutoff when it is in that sign startup routine, this right here. But that is how we get the really low speed startup. And I would highly recommend that you use that. All right, so that is how you do it. Let's go back to the overhead here and I'll show you how to unplug. You can pretty much do it in order that you would like. But I highly recommend that you paint your nails, then unplug the battery, then you unplug at the same time as fine or whatever of these guys. Now it is unplugged from, now we unplug the USB from the actual computer. If you unplug this from the computer and then plug it back in, let's go back to the computer right here. If you unplug it and plug it back in and try to program, it may not actually work. So I would recommend that every time, maybe even before you unplug the USB, that you close your connection out. It will close all of this down and it will leave you fresh for the next time that you want to plug it back in. Then you'll be able to select a port. Then you hit connect. you connect your ESC, then you hit the read settings, then you can load your firmware and flash your firmware and go about your business. The loading of firmware and flashing of firmware is really only going to happen whenever we have new ones to release, so maybe not so important every time, but you will have to at least connect to the ESC by reading settings on either the flash page, or I believe that comes up on the settings page as well before it will actually connect. And once again, you need the battery connected and the ESC connected to the programmer to do that. We are going to close out with some questions. If you do have any questions about this, we'll spend a couple of minutes here at the end and see if we can get any of them answered for you. But otherwise, that should be fairly self-explanatory. I do hope that helps out. We'll just zoom this camera out.
So far, we got a question about how do you have a sinusoidal wave in DC?
How do you have a sinusoidal wave in DC? That is a really good question. Essentially, it is an approximated sinusoid. And the best way to think about it is that there's inductance inductance of the motor. So even though it is a pulse width modulation and we are turning the DC on and off, and it is going from battery voltage down to ground voltage, the induction of the motor actually makes it where it's more of a slow rise. And if our pulse width modulation is quick enough, which 24 kilohertz is fast enough that if we chop that small enough that the effective wave shape is more like a sine. So in the programming, I can actually see the sine table itself. And what we do is we vary the pulse width modulation through that commutation cycle to start out at a small percentage and then get to a large percentage and then go down to a small percentage, effectively approximating a sine wave. So when you would actually look at the motor, through the inductance of the motor, it looks like a sine wave, but yes, you're totally right. This is chopped DC, and it is really nothing more than an approximated sine wave. So there's really no way with DC to have an actual sine wave output for three-phase unless we had inductance built into the ESC itself that would smooth it out, but that would just, man, that would wreck everything. So we essentially just use the inductance of the motor and also the inertia of the rotor to kind of smooth things out for us as well. So really good question there. I like those kind of questions. Anything else?
So far, that's it. Oh, people are asking what's up with the nail polish.
What is up with the nail polish? So my 5-year-old had a thing at school, or at least she told us there was a thing at school where we had to paint nails and there was a competition and we all painted nails and Daddy had to paint his nails too. And I did not remove that before today because I didn't have time. I forgot to bring the acetone and many other excuses that I could throw out there to you. But yeah, who freaking cares, really? It's just fingernail polish. So yeah, fun times with the 5-year-old.
Hey, how many grams is the ideal weight for a parts tray? People are asking.
How many grams is the ideal weight for a parts tray? Oh, man. I mean, if you live in a house that has a 20-mile-an-hour breeze all the time, I would say with a surface area of like 250 millimeters squared, you're going to want a parts tray that is at least 10 grams, if not more. We want to keep that wing loading pretty high. Maybe even a little higher than that, like 50 grams or so. It kind of depends on if your wind is variable, if you have gusts in your house, or if you have a steady stream, and also the edge of that parts tray. Let's see if I have any parts trays around here. The Holmes Hobbies parts tray is actually a flying edge. It is a flying disc, and that guy will take loft and it will fly with a little bit of air flowing over it. So make it as heavy as possible. You want that wing loading to be really high so it doesn't just fly off the table. Of course, you could also just, put stuff in it. And on this guy, 170 grams. If I'm going to go by the optimal weight of my parts trays that I use, I really like that between 168 and 175 is my ideal weight for a full-size parts tray. I'm thinking, tiny little parts tray, I guess.
That's about all we got for right now.
All right, that's all we got. So I do thank you for tuning in. We are going to do this as an uploaded video. The questions really helped, and I do hope this helped. If you have any more comments, please leave them.
Question.
Okay, we got one more.
David Chung said,
yeah.
Should COM be turned at the end of the set of brushes before a new set's installed?
Should you turn your COM on a brush motor before we install new brushes? Ideally, yes. However, I typically go 2 sets of brushes in between COM skims. So If it doesn't have big damage, if you haven't gotten into mud or anything like that, if it's just a normally used motor, then absolutely, I would usually go through 2 sets of brushes before I skim the com, and then basically every 2 sets of brushes. So we're going to call it there. If you do have further questions, no, we're going to call it there. We got to move on. Yep. So after this post, this is going to upload right after this. Leave your comments below, and then I will get to them there in the comments. Appreciate you tuning in. Hope this helps. Have a good day.